So a number is pulled out of a hat at random. What's the probability that 1/2 of n minus 2 is greater than or equal to 0? Yikes, 1/2 n minus 2 greater than or equal to 0. Let's do a little simplifying. Add 2 to both sides. 1/2 n is greater than or equal to 2. Multiply both sides by 2, n is greater than or equal to 4. So the question is, if a number n is pulled out of the hat, what's the probability that it's greater than or equal to 4? We're still no closer to solving it, but at least we'll have something easier to compare it up against. Statement 1 tells us that there are 6 numbers in the hat and each of them is an integer. But without knowing the values of those integers, if they're all negative, there's 0 chance of n being greater than or equal to 4. If they're all in the millions, then there's a 100% chance. So without knowing what the numbers are, statement 1 tells us nothing. So not A and not D. Statement 2 tells us that for every value of n in the hat, n is between 1 and 30 inclusive. Again, for probability, we need to know how many possible numbers are greater than or equal to 4 in order to figure out the probability of getting one of them. And since there are numbers in this range, some of which are greater than 4, some of which are less than 4, and we don't know how many numbers there are from statement 2, let alone, they all could be 30. There could be a hat full of 10 slips of paper with the number 30 written on each of them. Or they could all have 1. Again, there's not enough information in statement 2, so we get rid of that. Even using the two together, we know that there are 6 numbers, each between 1 and 30, but without knowing how those numbers are distributed, there's no way that we can know what the chances are of pulling one out that's greater than or equal to 4. We would actually need to know what's written on, imagining that they're each little slips of paper, we would need to know what's written on each of those slips of paper, or know something about their distribution to be able to answer this one. So even in conjunction, the two don't tell us enough to come up with the probability. Answer choice E.